So okay, so let's start question number 17. So what is asked in question number 17? This is a Cayley-Hamilton theorem. Again a very important theorem, Cayley-Hamilton theorem. Already they have mentioned what is there. It is satisfying, states that it satisfies its own characteristics equation. Means we know what is the characteristics equation, a minus lambda equal to 0. From here you will find the expression of lambda. So if you put in place of lambda a, then it should satisfy. That's what this is talking about all. So if you see what is your a is given minus 3 2 and minus 1 0. So if you do a minus lambda, you will deduct lambda from the diagonal equal to 0. So if you solve it, it will be coming lambda square plus 3 lambda plus 2 equal to 0. This is the characteristics equation known as characteristic equation. Okay. Now what Cayley-Hamilton theorem says, in place of lambda now you can put a. So in matrix it will be a square plus 3a. Matrix you cannot put 2 blank, so it should put 2i. So that's why it is 2i. Now what is saying that equation satisfied. Now you check with the options. So if you say option A, B, C, D, there are 4 options again. So none of the option seems to be satisfying, but if you say option A, the coefficients are matching 1, 3, 2. So why not multiply it by A inverse? So if I am multiplying post multiplication, matrix means matrix multiplication, pre-multiplication, post is different. Post means I am multiplying after a square, that is post. If you multiply before, then everywhere it should be before. So I am multiplying post, or here you can use pre also here, because scalar will move anyway. Scalar can move in between matrix also. So it will be a plus 3i plus 2a inverse is equal to 0, which seems to be your option A. So okay, so if it is done, then go for next 18. Okay, it is a linked question. So 17, 18 both are linked to same statement, that Cayley-Hamilton theorem. So here it is asked to find a to the power 9. Now how to find a to the power 9? So you need to use this expression. So if you use this expression, from here what will be a square? A square equal to minus 3a plus 2i. Minus, if you take outside, then it is minus 3a plus 2i. So we cannot go directly a to the power 9. So you can go a to the power 4, that is a square into a square. What is a square into a square? That is minus this into this. Matrix, you should not do a plus b whole square because it is matrix. So minus minus will get plus, because it is scalar, it can go out. Then you multiply 3a, it will be 9a square. Then 3 into a, 3 to the 6, a pre-multiplied with I, that is a. Here it is I, that's why there will be no problem. But if it is not I, then it should have been, suppose AB, then it is AB, this is BA, so both are different. So that's why you have to multiply in this way. That is 6a plus 3 to the again I into a, again a plus 4i. So it will give you 9. Again in place of a square, what we can put? Minus 3a plus 2i plus 12a plus 4i. So again if you simplify it, so it will find minus 15a minus 14i. If you do it, if you expand it, you will get it. So now if you got a4, now you can find a8. a8 will be a4 into a4. Second, if you do it, now you can think of, because it is I, now you can apply a plus b whole square, but it is not recommended because you have to check whether it is ab or ba, both are different. But as it is here, it is I, you can see, we can do it here. So it will be 225 a square plus 420a plus 196i, 14 square 196. So okay, in place of again a square, if you put minus 3a minus 2i, and rest is same. So if you simplify it, you will get the answer, that is 511a plus 510i. I am not simplifying it, plus minus you can do it. So you will get the answer, that is your option A. So if this is done, then let's go for 19. So what is 19? 19, they have asked the characteristics equation of a 3 cross 3 matrix is defined by this, some again Cayley-Hamilton theorems. One of the important thing in Cayley-Hamilton's theorem, if you find anywhere this type of expression, any algebraic expressions of A, any algebraic expression of A, anywhere in the question, if you find algebraic expression of a matrix A, some algebraic written by using a matrix A, then it should strike you that it is somewhere related to Cayley-Hamilton's theorem. Then you always check for Cayley-Hamilton, any algebraic statement using matrix in place of that variable. It is lambda, this is the variable, this is a polynomial. So here instead of lambda you are putting matrix. So if you find in the option or in the question something of this, then it should strike in your mind that it may be related to Cayley-Hamilton theorem. So to have a look on that one, on the Cayley-Hamilton aspect. So characteristic equation is given as, what is the characteristic equation? It is given lambda cube plus lambda square plus 2 lambda plus 1 equal to 0. This is the characteristic equation. Now I denotes identity matrix, then the inverse of the matrix P. So because it is given characteristics equation, and some in the options you can see it is polynomials P square P 2i, so it should be related to your Cayley-Hamilton's theorem. So what it states in place of this one, they have already given lambda I minus P. Lambda I minus P or P minus lambda I, both will give you same because it is the determinant only. Equal to 0, then it is same. Only minus sign will be difference, nothing else. So because it is 0, then it is okay. So it is P cube plus P square plus 2P plus I is equal to 0. So if you do it, so they are asking to find inverse. Now how to find inverse? So for inverse you can see you multiplied by P inverse. So it will be P square like this one, like your A, the earlier one we have multiplied by A. So it will be P inverse I plus P inverse equal to 0. So from here P inverse will come is equal to minus P square plus P plus 2I, which is your option D. So if it is done also, then we will move to question number 20. So what is 20? In M cross N full rank matrix, M is greater than N, and D and L is an identity and I is an identity matrix. Let matrix this may transfer is equal to, then which one of the following statement is false? Now what is given? This is given A dash is equal to, or A transpose. It's not transpose, they are defining it by A dash means this operation they are defining. So let's see what is this operation. This is minus 1. Let's see what is this operation. Let's simplify this one first. Now you can recall, I always give an example of this one in matrix. Suppose two friends of you are going together and there is a fly in your head. So if you want to remove that fly, these positions are interchanged. So in matrix it happens. So it becomes B inverse A inverse. AV inverse becomes B inverse AV inverse. So these positions will change. So it will be A inverse, A transpose inverse, then AT. So A transpose inverse and AT, A something same inverse, so it will be gone. So it is nothing but A dash is equal to A inverse. That's what they have given from the statement, giving this statement. If you simplify it, it will come like this. Now from the options you have to check which one of the following is false. Careful about false. So if it is a false, you first check all the options. Then A transpose is equal to A transpose, not, it is not transpose, A dash, a new operation they have defined by this, which is nothing but we have calculated inverse. So if you put inverse here, so A inverse equal to I into A is equal to A. Although this is true, but not correct answer because false. They have asked you to find the false. Net A into A dash. A dash means A inverse, then whole square, this will be I. So B is wrong. Okay, wait. There may be other surprises also. In D also it may state B and C. So then in that case D will be the answer. Both B and C are false. So if it is a, so you have to check the options before giving answer. So if we'll check, it is A into A inverse, this is I, okay, correct, true. So D is none, so none is not, none will be coming if A, B, C both are not, okay, but you have got one answer which is false, and the false one is the answer for me in this question, which is option B. So if it is done, then let's go to question number 21. So 21, what is they have asked? The rank of a matrix 5, 6 is 4. Then which of the one following statements are true? Rank of a 5 cross 6. 5 cross 6. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. So it is 5 cross 6. So the rank is 4. Now you can think of what is rank. We told calculation of rank. If you convert it into canonical form, the effective equations that rest becomes 0, number of non-zero rows. So if rank is 4 means this is 0 row. This entire row is 0. And rest are in canonical form. Suppose you have calculated, so non-zero rows will be 4. Okay. Now when these will be 0? I have told you in the equations, in the giving some examples of equations, if this row is depending on any of the rows or the combination of rows, then effectively you have not given me a new equation, you have given me a earlier equations, a modified version. Getting it now? I have already explained so many times. Suppose now I am explaining with a 3 cross 3. Suppose these two equations, these equations are given to you. Now a new equation, instead of giving new equation, once someone have given you by adding these two, 2 plus 1 3, 3 plus 1 4, 4 plus 1 5, 9. Now they have asked you to solve it. You cannot solve it because this equation is not independent. This is depending on this and this. So this is not a unique equation. So it will be 3 unknown, 2 equations. You will left with infinite solutions. So same here. If this is 0, that means this is depending on this. So okay, the statement, it has a 4 linearly independent rows. These are independent and these only depending upon this. That's why this becomes 0. Other remains non-zero. Now whatever I told you about rows, the same thing can be done in columns also. The same thing can be done in columns also. So you can guess the answer. So for column also there will be 4 independent column. Here it will be 4 independent rows. That's why the rank is independent. That's why the rank here is 4. They have given. You can check with anything. Suppose you have found 1, 2, 3, 4 after suppose let's take 3 cross 3 matrix. 0, 1, 2 and then 0, 0, 0. What is the rank of this one? 2. Now you can easily make this one also 0. You can also see that this, because this is 0, so these will obviously 0. You can make it 0 because rank is 2, so only 2 non-zero rank. You can do whatever you think, this minus 2 you will do. Our column 3 is replaced by column 3 minus 2 into column 2, then this one will be 0. Then finally do this one. Or let me do it, you will feel better. So it is column 3 minus 2 into 2 2s are 4, 3 minus 4 minus 1, 0, 1, 0, 0. Then it is 2 minus 2, 0, 0 minus 0, 0. Then one more operation, column 3 is replaced by column 3 plus column 1. If you plus it, then it is 0, 1, 0, 0, 2, 1, 0, 0, 0, 0. Now you are getting, this is 0, this is also 0. Why this is 0? Because the rank is here 2. Here for my example, rank is 2. So it will be 2 independent rows, these 2, and in column also 2 independent column. Both in row also, in column also. This is column and this is in row. So the answer is 4 independent rows, 4 independent column. So okay, that's all for today. We'll continue with question number 22. Till then, stay safe, stay home.